Recently I've been working my way through the first 100 Project Euler problems, and while the first 50 were easy, the last 50 are a bit tougher. A problem that particularly stuck out to me was problem 69, totient maximum, in which you're tasked to find a value n such that n is less than or equal to 1 million, and for which n divided by phi of n creates a maximum. This was an easy problem to solve by pre-computing the values of phi and then testing each possible value of n, but brute forcing was undoubtedly not the best way to solve this. So after getting accepted, I checked the solution guide for the problem, and I had some trouble understanding the optimal way to approach this problem. Okay, so we know that Euler's totient function phi of n gives us the number of positive integers that are co-prime to n up to n. If two positive numbers are co-prime or relatively prime, their greatest common divisor is 1. According to Euler's product formula, phi of n is equal to n times the product of 1 minus 1 over p for every prime divisible by n. Therefore, since we're trying to find the max of n over phi of n, we can put n in the numerator and the formula in the denominator and simplify, which simply gives us the product of p over p minus 1 for every prime p divisible by n. So how does this help us find a proper solution? Well, notice that the numerator will always be greater than the denominator. In fact, the lowest possible value with this formula is 2, because 2 is the first prime and 2 over 1 is just 2. Therefore, it is always in our benefit to continue to multiply more numbers together, because this will always create a bigger product. If you can start to see a solution forming naturally at this point, then good, but if not, here it is. We simply need to find the largest primorial that doesn't exceed our limit, in this case 1 million. Because we know that a primorial, p sub k, will be divisible by k primes, which will result in the biggest product from our earlier derivation.